The IRIS system uses a robust and scalable data collection framework. It collects data in various ways. In this video, we are going to discuss some of these methods: ICMP, SNMP, NetFlow, logs, traps, and IPSLA. ICMP. Let's have a look at ICMP first. ICMP monitoring is simply put a ping. Data is generated from sending a few packets to a specific IP address and waiting for a reply. From this, we can tell a few things. We can tell the availability. We sent 10 packets and 2 came back. We are able to determine that the device is alive, barely alive, but hanging in there. So we can say that the device is technically available. We can also tell that 8 of the packets did not make it. Of the 2 packets that made it, they took an average of 150 milliseconds to come back. This directly translates into the following graphs: availability, packet loss, and latency. SNMP. Another way that IRIS collects data is via SNMP. This is actually the primary method that IRIS uses. The Simple Network Management Protocol, SNMP, measures many different metrics from devices, assuming that they are SNMP enabled, of course. What can be obtained is defined by the manufacturer of the device. Manufacturers provide SNMP MIB files to define and help NMS systems like IRIS make sense of the data that the device can provide. Let's have a look at some examples of how SNMP works. IRIS asks the router, "On interface 1, how much traffic have you moved?" The router replies with 250 megabytes. IRIS waits 5 minutes and asks the router again. "And now?" The router replies with 265 megabytes. So with the difference being 15 megabytes, we know that in the last 5 minutes, the interface on the router moved 15 megabytes of data. This is called a counter. IRIS can also ask the router different questions, such as, "What is your CPU usage?" The router replies with 5%. After 5 minutes, the question is asked again, and the router replies with 4%. The CPU usage has improved by 1%. This is called a gauge. Stuff like interface traffic, errors, and quas are all examples of counters. Stuff like CPU usage, temperature, and voltage are all examples of gauges. There is a lot more information that you can get from SNMP, including descriptions, routes, and IP addresses, and a whole lot more, but we don't have time to talk about that now. NetFlow. Routers can be configured to send us NetFlow data. NetFlow is a protocol that Cisco developed and has been largely adopted by the networking community in various forms. You might have heard of terms like JFlow, SFlow, or maybe more recently IPFix. These are all more or less the same thing. NetFlow is used to collect detailed information about traffic moving through the router, such as source and destination IPs, ports, protocols, and so on. This information can then be reported on in IRIS. What is quite important with NetFlow is that the configuration is done correctly on the router and that IRIS is configured to listen for NetFlow data. We will talk more about NetFlow in other videos. Logs and traps. SNMP traps or syslogs can be sent to IRIS. This is also done by router configuration. Syslogs and traps are simply put messages that are generated by the device when something happens. It could be a problem, such as a shortage of memory, or just information, such as a configuration change. These messages arrive on the IRIS machine and are parsed to extract the information necessary to make a decision about whether it's an alarm that must be generated, as in the memory issue, or just something that must be logged, as with the configuration change. IPSLA. IPSLA was first implemented by Cisco on their platform, but similar mechanisms exist on other platforms such as Juniper RPM and Huawei NQA. IRIS can collect data from all of these. IPSLA is an IP Service Level Agreement protocol that does a test between two enabled devices and reports on this test. There are various tests such as an echo test, a jitter test, and a connect test to name a few. The way these tests work is that they are initiated between a probe and a responder. For example, the probe, usually on a router dedicated to IPSLA tests, will send 100 packets to the responder and measure the round-trip time, jitter, latency, packet loss, and emulated MOS score. IRIS is then able to poll the probe which initiated this request and get the data using SNMP. What is particularly useful about these tests is that they can be configured to run in different QoS classes, so that you could do a jitter test, which is typically a voice class, to determine if there would be voice quality issues of the network. IRIS is a data collection framework, and as such, there are many different ways to collect data. For example, we collect server information using WMI or NRPE. We generate stats from radius data. We can interrogate databases or even make telephone calls and collect the stats. We have just spoken about a few of these, and we hope this helps you understand how we collect data in IRIS a little better. Visit our website for more training.